Hey everybody, I am redoing this homework practice, these practice problems for the Mayan and the Babylonian system. And I'm using the same sheets that I did before, so I'm not going to redo those. So I'm going to cover it up and talk to you as we go through the problems. So just as a reminder, we've got the Mayan system, we've got the Babylonian system. Those are the two so far that are place value systems. Of course, in addition to ours. Ours is a base 10 system. The Mayans was the glitchy base 20 system, and the Babylonian was the base 60 system. So let's look at how we would change back and forth between these. Let me go over here to my document camera, and let's wait for this to focus. Come on. Okay, the Mayan system is the base 20 system, sort of. It's got that one place where it uses an 18 instead of a 20. Base 20, the word that goes with that is vigesimal. Decimal means base 10, that we're used to. Vigesimal is the word that goes with base 20. And we're going to take as our first example 9,435 and write that as a number in the Mayan system. So the first thing I have to do is decide how many of those places am I going to need. I know I need a ones place. I know I need a 20s place. The next place over would be 18 times 20, excuse me, which is 360. Well, I've got more than 360 here that I'm working with. The next place over would be 360 times 20. I've still got more than 7,200. The next place over would be 20 times that, which is 144,000. That's too big. All right. So I only need these four places in which I'm going to fill in my digits, and I've already done it here. So just ignore that. That's what we're going to go through in just a minute. So I know I don't need the 144,000s place. I just need 18 times 20 squared, 18 times 20 to the first, 20 to the first, and then 20 to the 0 power. Powers of 20 all the way down the line, except for that 18 that gets stuck in there. So the first question is, how many 7,200s are there in the number that I'm working with, 9,435, and that's just a division problem. So when I divide 7,200 into 9,435, I get a dividend of 1 with the remainder of 2,235. So that 1 right there goes in that spot there in my 7,200s place. That 1 means I've got 1 7,200. Okay, now I've got to take 2,235 and distribute that much across these three places. So my next question is, well, how much could go here? How much could go in the 360s place? So how many 360s are there in 2,235? Again, it's a division problem. 360 times 360 divided into 2,235. And that will go 6 times. That's my dividend with a remainder of 75. So 6 goes in that place for the 18 times 20, the 360s place. And then I've got 75 that's going to get distributed between the 20s place and the 1s place. So how many 20s are in 65? Looks like I did this wrong. I switched over to the base 60 system. So how many 20s are in there? 20 divides into 75 3 times, and 3 times 20 is 60. So I need 3 20s. 3 20s in there, 15 left over, so that 15 goes in my 1 place. So how would I record that? How would I write that down? If I just write down 1, then 6, then 3, then 15, how do you know that I'm talking about base 20 or the Mayan system? Well, here's what we're going to do. And this is because it's so difficult. I just can't do bars and dots on Canvas. So what we're going to do, the correct answer, if this were a quiz, this needs to be a 3. The correct answer would be 1, 6, 3, 15. I'm going to use commas to separate those places. And then I'm just going to write the word Mayan out there next to it. So when you see something that looks like this is in that Mayan numeration system. 15 is in the 1s place. 3 is in the 20s place. 6 is in the 18 times 20 place, which is 360. And then 1 is in the 18 times 20 times 20 place. Okay. So let's go the other way. Suppose you've got a number in the Mayan system and you're changing it to the Hindu Arabic system. So this number is written with Mayan numerals. I'm not using dots and dashes. I'm just using the numerals that we would use, the Hindu Arabic numerals, and using commas to separate the places. So the 4 is in the 1's place, the 13 is in the 20's place, and the 3 is in the 18 times 20 place, which is 360. And so this one, here's why it's good to have a calculator handy when you're doing some of these problems. So it's just a matter of multiplying and adding. So I've got 3 360s plus 13 of those 20s plus 4 of those 1s. And when I use my calculator to add all of those up, I get 1,344, which is the way we would write it in our system, which is a base 10 system. And to make sure you remember I'm using base 10, I wrote a little 10 down there. Okay. And when you don't see anything there, you can assume that we're talking base 10. Okay, now one more example going in the opposite direction. Suppose we take 3,134 in base 10, and we're going to rewrite that as a Mayan numeral. Well, again, the first thing I have to figure out is how many places am I going to have? I've got a 1's place, I've got a 20's place, I've got a 360's place. 7,200, that's too big. So I've only got 3 places. So ask the very same questions that we did before. How many 360s are there in 3,134? There are 8 of them. Do the division, you get a remainder of 254. How many 20s are in 254? There are 12 of them. Do the division, you get a remainder of 14. That's how many 1s you've got. So how would I record that? I would write 3,134 in base 10 is equal to 8, 12, 14, and there's the Mayan system. Now, you've also got 3 examples where you can go back the other way here now, because now what you can do, I mean, it's not like you've got these memorized probably. You're not going to remember exactly what the answer was. Go backwards. Start with this number in the Mayan system, change it to the Hindu Arabic system, and see if you end up with 9,435. Take this number in the base 10 system, change it to Mayan, see if that's what you end up with. Take this Mayan numeral, change it to Hindu Arabic, see if that's what you end up with. Okay. Now let's talk about the Babylonians. And the Babylonians are going to have their very own module. So the next module is on the Egyptian mathematics, which is covering more for both of these, Babylonians and Egyptians. We're covering more than just the numeration systems. We're looking at how they solved some problems. So you'll come back to this sexagesimal system module after next. It's base 60. Sexagesimal means base 60. We're going to take 9,435 again. And the first question is, how many places do I need? Well, I need a 1's place. I need a 60's place. I need a 60 squared place. That's 3,600. If I go to the next one, 3,600 times 60, that's 216,000. That's too big. So I know I don't need 60 to the 3rd power. Way too big. I just need to go up to my 3,600s. And I've already got the answers filled in, but let's talk through it. So the first question is, how many 3,600s are there in 9,435? It's a division problem. Just do the division. And if you're going to use your calculator, you're going to have to do a little bit of finagling to figure out what the remainder is, because that's really important. You can't just leave it with the decimal. You really need that remainder right there. Because now my next question is, taking that remainder, how many 60s are in that remainder? Because that's going to give me the digit that goes in that next place, 37. 60 divided into 2,235 gives me 37 as the dividend, and the remainder is 15, which is my 1's digit. So the 2 is the 60, goes in the 60 squared place, 37 goes in the 60s place, 15 goes in the ones place. And I would write that 2 comma 37 comma 15 base 60. Okay. So if this were a question on your quiz, you'll have an A, B, C, D, and E, and maybe A looks like 2 comma 37 comma 15, and B looks like 37 comma 2 comma 15, and C looks like 15 comma 2 comma 37. You know, all different kinds of things in there. Okay, so again, you've got another problem here. Now wait a little while, take this one and go backwards. Okay. Now let's go the other way. Let's take a numeral in the Babylonian system and let's change it to the Hindu Arabic system. So 3 comma 13 comma 4 is in base 60. 4 is in the ones place. 13 is in the 60s place. 3 is in the 60 squared place, which would make that 3600. So I've got 3 of those 3600s. I've got 13 60s and 4 ones. Got that written out right there. 3 times 60 squared plus 13 times 60 plus 4 times 1 equals 10,800 plus 780 plus 4 equals 11,584 in base 10. I didn't have my calculator with me before when I did that arithmetic. So there you go. Give it a little while. Go back and practice with the Mayans and take this one and go back to the Babylonians. When you take 11,584, you're only going to have 3 decimal, or you're only going to have 3 places. Well, that's because with that base 60 is so much bigger, you don't need as many places with that base 60. Okay. There are other examples with these and with the Egyptians and the Roman numerals back in your book. And of course, even if you need more, it's easy to find more on YouTube, on the internet. Send me an email. I can send you some more. Not a problem at all. All right. You should be good to go then. If you've read all, worked through the PowerPoint, read everything that you need to read in that first module, work through the homework set, you're good to go on the homework quiz, then review everything and do the reading quiz. All right. See you soon. Bye-bye.